Okay, this is a problem that's just a reminder about yesterday's. Yesterday's was about solving quadratics that are built into logs. And this one's a quadratic because as soon as you squish these two together, see, they're expanded right now with this plus, and you're going to be able to put them together. That's going to turn into log of x plus 2, x minus 2. Look at that, they're being multiplied. And then this 2 right here can go up on top of that for that exponent. It's going to be log 2 to the second. And then since these logs are the same, this will cancel. And then we get to the part where it's a quadratic. Would you please solve it from there? You're going to have to get everything to one side and set it equal to 0. And then I don't think it's going to factor. And then you'll have to remember what to do when you can't factor them. So multiply it out first. Then get everything to one side so it equals 0. All right, so here's what you should have done. You go x squared, and the plus 2x and the minus 2x, the outside and the inside, they cancel each other out. So it's just minus 4 equals 4. Geez, we're almost done here. So we're going to add 4 to both sides. X squared equals 8. You know what I'm doing? And then I'm just going to take a square root of both sides. I'm going to use the square root symbol this time. And then I'm going to have x equals the square root of 8. There you go. I was hoping somebody would say that. Because when you take the square root of both sides, you got to remember you technically have absolute value of x. And that means x would be plus and minus the square root of 8. All right. Raise your hand if you had that one right. All right. So about half of you. Now, yes, you absolutely could make root 8 into root 4 and root 2. And then all of a sudden, root 4 simplifies. 2 root 2. So plus and minus 2 root 2 is even more smarticle, as my daughter used to say. All right. There's another kind that's definitely harder. I'll go something like this. There, I'll even set it equal to 0 for you. This one, you're going to have to do a U substitution, where you're going to pull out the complicated part and replace it with a U. Give it a try, Robo iPad guy. That's a really big, oh, okay. It's got a block in there to keep it away from your body, huh? All right, for those that aren't sure how to start, a reminder. Whenever you see one that's something squared, and this is not cubed. It may look like it's cubed, but just the x is cubed. That means this 3 goes down in front like this. So that's something that's not squared. So something squared, something not squared, and then a number, it often can be a quadratic. So you let u equal log x. Why is that good? Because you can replace this big complicated thing with just a u squared minus, throw down 3 log x instead of log x and replace it with u. And then I'm going to say minus 4. And the good question I was just asked was, why couldn't you just say x equals log x? Just think about that. If you say x equals log x, do you get how that's a problem? Because x doesn't equal log x, really. Because then it's really saying 10 to the x is equal to x, which is a little weird. You know what I'm saying? So yes, you could use y. Why am I choosing the letter u? Because in calc, they do a whole unit called u substitutions. The standard thing to use in calc is the letter u when you're going to pull something out and replace it with something. So just get used to the u. Fine, use x. It actually works to use x, but just so you know, it makes more sense to like get used to the u thing because that's where you're headed in the future is calculus. Oh, poor. I don't know what you are talking about, but all right. So hopefully from here this factored. Did it factor? But why? Oh, that's bad. Okay. U, and then U, and then I got to make a -4 and a +1, I think is how this works, right? And then I have two answers. U minus 4 has to equal 0, or U plus 1 has to equal 0. And that means U has to equal 4. And this means U has to equal -1. But I'm not done, because I sort of made a deal with the devil back at the beginning. And now I have to pay him back. I was able to make life a lot easier by doing this one little substitution. Now I have to go back and pay it back. And the U has to become log x. So now log x equals 4, and log x equals -1. And then I have to do a rewrite. It is really, really common to have to rewrite logs and make them exponentials, or vice versa. 10 to the 4th equals x, or otherwise known as x equals 10,000. And a lot of people get confused by that because they think, oh, a 10 and then you add 4 zeros, isn't it? No. It's a 1 with 4 zeros. I can prove it. It's 1 times 10 to the 4th, right? And that just takes the decimal, moves 4 spots. So anyway, and this one is 10 to the -1, which just means a fraction. 1/10. So 1/10 would work, or 10,000 would work. And now neither of those is negative, so it's not likely they would crash my original problem. But I would, if my life depended on these answers being right, I would take them, stick them back in, and find out if it really works. And wherever I see x, I'd put 10,000. So that would mean a 10,000 right here. And that's really like log base 10 of 10 to the 4th. So this whole thing becomes a 4. And 4 squared is 16. Minus 3 times 4 is 12. 16 times 12 is 4. And 4 minus 4 is 0. And it worked. Awesome. Okay. Anyway, that was yesterday's stuff. How about today's? Today's a lot harder? No, it's just different. And in fact, it's actually easier than yesterday's. Today's is about, you have weird things that you have to try to change the base on. Like, for instance, let's say that this one's not as bad, but log base 27 of 3. Now you remember how if both of these are 3's, you know, if this was log base 3 of 3, then the answer would be 1. And if this was log base 3 of 3 to the 8th, then the answer would be 8. Remember those? If these are the same, I'm good. But these two aren't the same, and people are really tempted to take this 27 and rewrite it as like 3 to the 3rd. But you can't do that. You have to leave bases alone. So you have to leave that as 27, and this 3 here has to get replaced with 27 to the something. So just realize what you're trying to do here. You're trying to make this into a 27 to the something. So you could write it this way. You could say, I want this to be log base 27 of 27 to the something, or another way to say it is 27 to the something has to equal 3. Do you get what I'm saying? Now, if you have trouble solving this one, I know this one is a pretty easy one to do in your head, but I'm trying to tell you, you can write a little equation for what you want and then solve it. Remember the common base thing? What if these are both at the same base and so on? Then you can make the 27 into a 3 to the 3rd. Do you get what I just did there? And so then the bases are the same, and so 3x has to equal 1. So x equals 1/3. The reason I just did that is because, I'll give you an example of one. Do you get that I really want that 18 to be 9 to something? And some people will just plain screw up and think, oh, 18 is 9 squared. It's not. So you could not go log base 9 of 9 squared equals x, because 9 squared isn't 18. So I need this to be 9 to the something has to be 18. I don't know what this is. I shouldn't call it x. So here's where I'm saying you should go off to the side and say, I want 9 to the something to equal 18, and then solve it. So then 9 to the something has to be 18. What's 9 to the 1? What's 9 squared?
81.
So it's got to be between 1 and 2. So it's got to be some kind of a fraction. All right. All right. Okay, so 9 to the x equals 18. How am I going to finish this thing? I'm not saying who it was. I don't want to embarrass them. I just want to wake them up. All right. So I can do anything now to both of them. Got any ideas? Yes, you're onto something. Log base 9 of 18 equals x, but that's the original problem. Is there any way to do this? Oh, yes, there is. So, say it, yes. What? Log 18 divided by log 9. Now, is log 18 over log 9, can I break up the log 18 into two things? Okay. This is log 18 is really log 9 plus log 2. And both log 9s cancel out. And then if you don't know anything about canceling, you'll think you can do this, but you can't. You're not allowed to do that because there's a plus in there. Can or can't you cancel? You can't cancel in that one. Okay. Rage quit? Just use your calculator and you could go log the 18 over log 9. But the ones we're going to give you, you can always figure out. You can always figure out they're going to be a fraction. All right, so let's do one that you'd actually could figure out this way. Log base 8 of 16. So again, you really wish that was an 8 to a power. Figure out what power it'll be. It'll be a fraction. It'll be a challenge. Figure it out. So again, we want this. Log base 8 of 8 to the something. And as soon as I figure that out, I'm done. X will equal whatever the question mark is. It's got to be some kind of a fraction that takes 8 and turns it into 16. First, remember, if it's going to be a fraction, then there's got to be a root involved, right? Like if there's a fraction, if there's going to be something on the top, something on the bottom, do you get that the thing on the bottom is the root? There's only one kind of root I can take of 8. What kind of root? No, not the fourth. The third root. I can take the third root of 8. What is the third root of 8? 2. And then I got to build it back up to be 16, so 4. There we go. Because, here, think of it this way. Do you get that this 8 to the 4/3 is the same as 8 to the 1/3 and then also to the 4th? This part made it 2. 2 to the 4th makes it 16, and that's what I wanted it to be in the first place. All right. So final answer is, now that I got this, the hard part was figuring out the 4/3. The answer is 4/3 then. X must be 4/3. Because if you have this number and this number the same, that's the answer. All right, so there's a lot of that kind of stuff today. So let's do a couple together. Here comes your worksheet. And then we'll be out the door to lunch after we do a couple of these together. Is it Tender Tuesday? Apparently it's the Tender Tuesday. All right, here we go. First one. Numero uno. It just says log, Mr. Server. There's no base on this first one. Yes, there is. What is it? 10. Base 10. So then, if this was only 10 to the something, but it is. Log base 10 of 10 to the what? What's that question mark got to be?
1 over.
It's got to be negative because you want it to be a fraction. And can you say this correctly? That's not 1/10. What is it? 1/100th. So I'm gonna start by saying that. It's the same as that, right? And now I'm going to go log base 10 of, what can I do with the 100th to make this work? 10 to the what? 10 to the 1/2 would mean the square root of 10. I don't think that's what you want. Negative makes it flip in a fraction, yes? 2, you are correct. And 0.01 is 10 to the negative 2. Think about it. Okay, so now this is the answer. So x equals negative 2. So it's all about, well, these can be done with rewriting too. I want to show you how that could look. So look at number 2. Number 2 says log base 27 of 3. Did we do that one in class already? All right. And I'll just show you how a rewrite would have looked. I can go 27 to the x equals 3, and you got to make the bases common. This could be 3 to the 3rd to the x equals 3, and that's going to mean that these bases can cancel, and that had an exponent of 1. 3x equals 1, and x equals 1/3. So there's the recap of number 2 that we did before. Moving on to number 3. We just did that one in class too. Let's go number 4. Number 4 is log base 1/5 of 5. And people are really tempted to change the base. You do not do that. You can't do that. Thank you. And it can be changed, though, this way. Log base 1/5 of 1/5 to the something. If I could just get that 25 to be written as a 1/5 to the something, negative 2 is correct. And then you'll have your answer. All right. You got it. All right. I want to flip to the back side because there's one that's medium challenging back there. Let's look at number 14. Number 14 is log, parentheses, x squared plus 36 equals 2. And then I'm thinking this is base 10. And if there was only a log on both sides, I could cancel the logs, so I can't do that. But what can you do? Use the word that starts with R. Rewrite it. So that means 10 to the 2nd equals that. 10 to the 2nd equals x squared plus 36. Does that look like a quadratic to you? It's a not perfectly formed quadratic. You need to rearrange it, get it equal to 0. Then maybe it'll factor. If it doesn't factor, you can use quadratic formula. All right. Okay. So that's all the advice I have for you on this one.